Hello there, chemistry students, and welcome to our 8-27 lab on double displacement reactions. In particular, we are going to be looking at precipitation reactions, which are a type of double displacement reaction where the driving force is the formation of an insoluble solid. If you recall the other driving forces, there are two other driving forces behind double displacement. One of those is the formation of a gas as a product, or the formation of water, which is common in an acid-base neutralization reaction, which is a specific category of double displacement reactions. Double displacement reactions go by other names. Some people call them double replacement. Some people call them net ion exchange, where one compound's ion exchanges positions or places with another ion in a nearby compound. This is a video lab, so we'll be watching a video. This lab you'll have 2 days to complete. You can work on this lab Thursday, the 23rd of April, and hopefully get it finished by Friday, the 24th of April. So you'll have 2 days to work on this lab. And that should not be any problem, but the idea here is to not rush through this lab, to take your time and to make sure you understand what we're doing. Since we are not in the classroom, we're going to watch a video of this lab being performed, and we'll make observations based on what we see. Our whole idea behind this lab is to actually observe reactions where double displacement reactions could potentially be happening, or ones where they might not be happening. And ultimately, by looking at many examples of double displacement reactions and observing them, you can understand or begin to understand how they establish the solubility table. And from the solubility table, you'll have an understanding where they come up with the solubility rules, which are generalizations based on what happens in the solubility table. So you're going to be watching, in the first part of this lab, you're going to be watching several double displacement reactions. You'll be looking for the formation of precipitants in this lab, but it is not easy to see in the first part of this lab. Later on in the lab, we'll watch ones that are very easy to see. But what you'll have to do is make your best guess as to whether a precipitate forms or not. You'll be looking for the formation of a solid when the two solutions are put together. And the big thing is to not get confused by what you're seeing, because very often aqueous solutions of salts have their own colors. So a color change itself, when you put two different colored solutions together, a third color could appear. What you're really looking for, though, is can you see solids precipitating out of the solution? Again, it's not easy. Just do your best. I'll also provide you with a solubility table, which gives you what you should see if you are actually able to see it better. The solubility table I give you will have question marks on them, and those question marks are there because of different reasons. Sometimes when you do precipitation reaction, sometimes the product you're forming may not be stable and it itself might decompose. Other times there's question marks where the precipitate might form, but it's only partially soluble. So you have precipitates that are insoluble and some that are partially soluble. You're going to make your observations on a data table. Let's take a look at the data table. This is the data table where you'll be making your observations. The solutions down here on this side of the data table are one of the solutions that you're using. On this side of the data table are the other solutions you're using. The part from this solution going down the vertical column, it is the metal ion that we're looking at, the cation, and we're looking to see how it reacts with the anion in this solution. So for instance, in rectangular box square number 1, we're going to be reacting potassium hydroxide with cobalt 2 chloride. But what we're really trying to see is, does cobalt 2 hydroxide precipitate from solution? The spectator ion in this is potassium. The alkali metals are always soluble. And over here, the anion, the spectator anion, is chloride. So the chloride's not doing anything in the cobalt 2 chloride, and the potassium's not doing anything in the potassium hydroxide. So that's how this table is laid out. The things that we're actually looking to see if they react are the red ions and the green cations. Down here underneath, we have what the result should be based on the experiment being replicated and completed. This is what should happen, but once again, it's not really good chemistry when you immediately conclude what should happen based on what you think is happening. Your observations can override any of these things. The only reason we're providing these for you is because it is difficult sometimes to see. Once again, where there are question marks on this table, those are places where it is either partially soluble or the precipitate might be decomposing, many different things. And there you can make whatever guess you can based on what you see. It doesn't really matter that much. After you've completed all these reactions, if you notice there are numbered boxes here. These numbered rectangular boxes correspond to the numbers that you'll see in the calculations part, where you're actually going to write balanced chemical reactions for the ones that happen. So if we look right here on row 1, we're reacting cobalt 2 chloride with potassium hydroxide. That's box 1. If you look down here, you see cobalt 2 chloride reacting with potassium hydroxide. If you actually see a reaction happen, if a precipitant forms, if the precipitant is insoluble, that means the reaction will happen. And what you'll need to do is come down here and complete those reactions for the ones that happen. If the reaction does not happen, if there is no reaction in the boxes right here, when there are no reactions, you'll write an NR. No reaction, you did not see a precipitant form. If you see something happen, it's RXN. That stands for reaction. If there's no reaction, it means that the solution or the products that you formed both were able to be soluble in water. If you see a reaction happen, that means the product is insoluble. It will precipitate out of solution. So for instance, on number 5 right here, in box number 5, you're going to be reacting copper 2 sulfate with potassium hydroxide. Copper 2 sulfate with potassium hydroxide. That's on row 2. Number 5, copper 2 sulfate in potassium hydroxide. If you'll notice on some of the numbers, there's an asterisk. When you see an asterisk, those correspond to ones that had question marks on the table up here. So where you see question marks, for instance, will a copper ion form a precipitant with iodine? There's a question mark there. There's a question mark there. We look down here. If you notice, there's an asterisk right here. That means whatever you think you saw, go with it. If you thought you saw a precipitant form, in other words, the product's insoluble, write a balanced chemical reaction. If they were both aqueous and no precipitant formed, then you will write no reaction, NR right there. That is how we are doing these. And there should be 24 reactions where you're either writing NR, you're making your best guess if it's an asterisk next to it, or if you see a reaction happen, you'll write and balance the reaction. Remember, in double displacement reactions, it's the first thing here reacting with the second thing here. The first thing here is joining up with the first thing there. That's double displacement. Net ion exchange means this ion is exchanging places with that ion. The metal ions exchange places. As we mentioned, many of these are difficult to see. So we are going to watch a couple of double displacement reactions, a couple precipitation reactions that are not hard to see, where it is done on a scale where you'll definitely watch what is happening and just follow the instruction, what they're asking you to do. For instance, you will see a reaction here on this one. Write and balance the reaction and tell me what color the precipitant is. That should say what color the precipitant is. Down here, there are some really awesome ones to watch. On these, you do not have to write and balance them, but these are just really cool precipitation reactions that you get to see. We mentioned that the solubility table has trends or general patterns to it. There are trends on the solubility table where certain types of compounds, certain anions, certain cations tend to be very soluble or not soluble at all. And what we are going to do for the conclusion of this lab is take a look at what things we learned in this lab that we could use to fill out the solubility table. And if we did enough experiments, what trends would we see? So we have a video telling you what are the rules, what are the general solubility rules in our conclusion. What are the general solubility rules? And taking us through the general solubility rules is the great Mr. Causey. Mr. Causey produces some outstanding videos, and Mr. Causey is adamant that it's important to understand the general trends or the rules of solubility as you understand chemistry, and that will be our conclusion watching this video. There will be an answer key posted to this lab so that as you're going through this lab, you can check against the answer key to see how you're doing. Please do the lab first. Don't immediately go straight to the answer key and just write down what you see, because as you know and I know, doing it and actually getting an opportunity to see this lab performed is better than just telling you what should happen. So take the time to watch. Take the time to try to practice writing your own equations and then consult the answer key. If you have any questions as you go through this, please email me your question. We can set up a meet, or we can do other videos, or merely answer the question for you directly through email. But please come away understanding this through this lab. Again, we have Thursday and Friday. This is a 2-day lab, the 23rd and the 24th. Good luck.